Now we're going to look at properties of logarithms. You've had the conversion rule. You need to be able to go from logarithmic form to exponential and back. Common log, if all you see is log x, log of x, and you don't see anything here, it's understood to be 10. Or if you have ln x, it's understood to be base e. Recall these rules. These are your exponential rules. You have a base raised to a power times same base raised to a power. Remember, I can simplify by keeping base, adding exponents. Base raised to power being divided by same base raised to power, I simplify by keeping my base and top exponent minus bottom exponent. If I have a base raised to a power and that in turn is raised to a power, I can simplify by keeping my base and multiplying my exponents. Now, properties of logarithms. Some of these you've seen, others you haven't, so we'll be looking at those in just a second. If I take log of 1 to any base, remember my base has got to be greater than 0, it's going to equal 0. Because if I rewrote this in exponential form, I'd have a to the 0, and that would equal 1. So if you press your log key on your calculator and then press 1, it should give you 0. Same thing if you press your ln key and 1, it will give you 0. So if I have a log of a number and the base is the exact same thing, remember this right here is an exponent of 1, it equals 1. Now if I rewrote this, this would be a to the first would equal a, and anytime you have a base raised to the first power, you get that base right back. So press log on your calculator and type in 10, because remember log is base 10, and then if you hit enter it should equal 1. You've seen this one, we've had this one. Anytime your base here is the same as the base here, whatever your exponent is, that's your value here. Product rule. The log of a product to a base is equal to the sum of those factors to that same base. Think of your old multiplication symbol. Remember, it was an X. If you rotate it a little bit, you'll have a plus sign. It's a way that you can remember. A log of a product goes to a sum. Quotient rule. When I have the log of a value being divided by another value, I can subtract those two. See this sign right here, separating? Now remember, I've got a little subtraction right here. Power rule. If I have a log of a number raised to a power to whatever base, that exponent, I can move it out front. So this is my power rule. So I've got product rule, quotient rule, power rule. Now I've got one proof here for number 4, my product rule. And, you know, you haven't seen any proofs in here, so let's look at this proof. And this is what math people always do with proofs. They always start with a let, and that means they're about to set you up. So if I let log u base b equal x and log v base b equal y, well, if I rewrote this using, I can rewrite these as exponentials. I can have u equals b to the x and v equals b to the y, right? Going from logarithmic form to exponential form. Now, next part. Well, what if I decide to do u times v? There's my u times v. Well, if we do u times v, well, that's the same thing as b to the x times b to the y. And remember, I can simplify this since my bases are the same. That would be b to the x plus y. Okay, next part. Well, what if we wrote this last one into logarithmic form? I would have my x plus y, okay, equals log uv base b. So let me move this down just a little bit. I'll just delete it. There. Okay, here's my x plus y equals log uv base b. But remember at the very get-go, what x was and what y was. So with substitution, I'm going to put log u base b here, and here I'm going to put log v base b, and that's a proof. Now the other ones can be proved the same way, but if I have the log of a product, I can separate it up as a sum of those factors of those logs. Big note. Notice, big red note here. There is no distributive property in logarithms. This is not equivalent, because this right here, when I have addition, is when these two are multiplied. So if I have a log of a sum or a difference, it has to stay the log of that sum or difference. Now Qprop. What we're going to be doing with these properties is we're going to be expanding and condensing. And a lot of students have some difficulties because they don't know where to start. So some years ago, I was reading the newspaper, and C-Ray had this brand new propeller, and it was called Qprop, and I thought that was cool. And I kept reading, and then I went, wait a minute, I could use this for expansion of logarithms. First thing we look for is quotients, then we look for products, and the last thing we do is powers. Okay? So it says the quotient, product, and power rules of logarithms were used to rewrite, if possible, each of the following logarithms. And I'm going to look at these. Now these are examples of expanding. And when I expand, I go this way. I look for quotients, then I look for products, and then I look for powers. Well, the first problem right here, I see a quotient. Remember, we separate with subtraction. So I'm going to have log 6 base 4 minus log 7 base 4. Now here, I've got a product, I've got a quotient, but I start with quotients first. So the first thing I'm going to do is separate numerator from denominator. So I'm going to have log 4p base 3 minus log q base 3. Now I have to go back, make sure I've got product. I've got a product right here. Products are separated by addition. So I'm going to have log 4 base 3 plus log p base 3 minus the log q base 3. Now guys, that's expansion. Started with one single log, and we've expanded that to single values after each log. Now here's one very similar to this one, and I usually tell my students, don't trust a log that has a numerical base, and I'll show you why in just a second. So first thing, I see quotient. See quotient? So separate top from the bottom by subtraction. I gotta move this little fella over. Okay. Next thing, I've got myself a product right here. I separate by addition. Now remember, this right radical means a 1/2 exponent. So let's see what I did right here. Okay, see my 1/2 exponent? So if you see radicals, you're going to have to change them to fractional exponents. Now this is why I tell my students, don't trust a numerical base. Remember log 2 base 2? This equals 1. What if this was log 4? Guys, if you can rewrite that as 2 squared, then this would be 2. So I'm going to have a 1 here. Exponents come out front. That's the last thing, the power rule. So that comes out front. So let's see how this thing simplifies. So this is 1. The 1/2 comes out front as a product, and everything else is just written as is. This one, we don't have a rule that deals with addition subtraction, so this has to equal itself. Remember, we cannot distribute this through. No. This one, well, I see a quotient, I see product, I see powers. So first thing, quotient. Let's go separate by subtraction. And notice I've got a z base and I see no z's, so that makes me happy. Got myself right here a product. Separate by addition. Powers, bring powers up front. Move them as factors, as products. So there it is. And you can't tell me that that's not expanded from the original. So if they ask you to, expand the logarithm, you'll have a single one, and boy, you're going to have a real good time. This must be fairly big and complicated. First thing, I see a cube root. Well, guys, first thing I'm going to do here, that's 1/3. Remember, that's written as 1/3. And then, with my rules, I've got all of these followed by taken to the 1/3 power, so distribute. Now we're free to go here. I've got a quotient, and I've had products and powers before. So first thing, let's make this, turn this to a subtraction, separate numerator from denominator. Next thing I have to worry about, remember in Q prop is products, so I've got a product right here, and they're separated by addition. And now I've got little tiny baby powers that I've got to bring out front as products. So there it is. And guys, if you're asked to expand, you're going to also be asked to condense. Now think about Q prop. If I go this way to expand, does it make sense I have to go backwards to condense? So I'll be looking for powers. Remember where they're located, in front of the log. Products, well, if I see a product, that means there's an addition. And then my quotients are separated when I've got subtraction. So let's see what we've got here. I've got parentheses, so they want me to do this first. Since I see subtraction, this can be singled down to a 1 logarithm as log k over m base b. And I still have that other one. Another subtraction, so that will be this k over m divided by a after my log base b. But they're not going to leave this. Remember, this is k divided by m divided by a. When you divide fractions, remember you get the reciprocal and multiply. So this would be k over m times 1 over a. So that would be it. Notice from more than one log to a single log. So now these, I see numbers out front, so I've got to take those back in as exponents. Oh, the next part, let's see. We can go ahead with addition. We can multiply. Let's see if that's what happened next. Nope. First thing, if you have a numerical base, a lot of times they'll go ahead and find out what that is. So 5 to the 3rd is 125. 9 to the 1/2 is the same thing as square root of 9. So they went ahead and did that. So now I get to multiply these because that's addition. It's supposed to be a little times sign there. And if you multiply that, it'll give you 375. There you are. Why don't you try this one? What do you do first? Hopefully you said you take the exponent in. Remember, I've got to do Q prop in reverse. Okay? Now, you might leave this as a 1/2 power, or you could make this as square root. Either one would be acceptable. The next thing, I've got subtraction, so that means a quotient. And that's it. So, from more than one logarithm, it's condensed down to 1 using the correct properties. And that's all for this one. Thank you.